Welcome to this week's Swarf and Chips. I'm joined in the studio this week by Paul and Gio, and we have a great show coming up for you today with educational features and reviews from across the UK. So we start with Mark's recent visit to Tru-Tech in Ireland, who have revolutionised their component manufacture with their new X-Tech EDM investment. Gio tries to explain the difference between full fifth axis and 3+2 at Advanced Engineering UK Ltd. It's really good. But was he correct? He also discusses work holding options and considerations for a single spindle CNC lathe at European CNC. We also look at Colin's visit to Truturn for reviews and application examples which illustrate improved efficiency and capability gains using citizen sliding head machines. And finally, a cycle time challenge at Finetec. It's going to be a good one. It's going to be a jam-packed show today.
Be as good as last week's, won't it?
Yeah, exactly. That was really informative though last week. We learned a lot and I like that. And I like your educational shows, Gio.
Thanks, Lindsay. Yeah. And hey, Paul, have you got any jokes today anyway?
Oh, I've got loads.
No,
not clean enough for this.
And none about crab sandwiches.
No. Not after the complaints we had last time.
Any updates, open houses?
They're starting again, aren't they, Lindsay? The podcasts are going really well, so keep an eye on them. And any subjects that you want us to cover, comment and
three podcasts: automation, metrology, and
finance.
Oh, yes.
Don't say that about finance. It is actually really interesting, but no one wants to know about finance.
It's a false yawn.
Right, okay, let's start the show at Tru-Tech with Mark in Ireland talking X-Tech EDM.
Guys, I've travelled in a car, on a plane, and now I'm in Ireland. Now, Paul, you represent Warrick Machine Tools, and we're one of your customers, Tru-Tech Precision Engineering in Dundalk. Now, these guys have been a long-term customer of yours, and some of the products that they're actually making here, they've been using mainly grinding application until you sold them this X-Tech V400G wire machine. Now, how long has it been for them to actually sort of bring the cycle times down?
Well, yes, I mean, we originally sold the machine to Tru-Tech, and they were using their machine in the medical industry, and they were also making some carbide components on a grinding machine. Suddenly they realised, oh, we can do this with our wire cut machine, and as a result of that, now they can program the component, pop the program in the machine, and cut the component in 25 minutes. Previous to that, it was an hour and a half on a form grinding machine.
Now, I think there's some benefits with EDM, isn't it? Because some of these parts have been sub 2 microns, aren't they?
That's right, yes. And also there's some very sharp details which are involved as well, which we can obtain very, very easily on a wire cut machine.
And I think the benefit with your knowledge in the marketplace is a lot of the companies over in Ireland, until they speak to you, think, can I do this in a better way? This is obviously where the X-Tech machines are becoming principally a very good sale in Ireland.
That's right. It's by being over here and talking to people and looking at their applications, very often we can save our customers time and money.
Well, there you go. Thanks very much, Paul. Knowledge is power. Just think about that, Lindsay.
Thank you, Mark. And sharing your knowledge empowers others. I know, and that's what we do.
What if you haven't got any knowledge?
Knowledgeless.
Have you not got any power?
Yeah, then you got no power, and then that's it, and then that's the end, and then that's the end.
I like where these guys were located. Dumbledore, something like that. Fascinating to hear again about EDM. We've done a lot of activity on EDM machines with these guys, with Fanuc and various others, and it is opening up new opportunities. They're getting new opportunities opening up to them, these machine suppliers, because of the capabilities of what the machines can do these days. Certainly with even PCD tooling, there's a lot of grinding operations or products that used to be ground. You don't need to do it anymore. The EDM is a perfect solution. It's a more cost-effective way of manufacturing.
Yeah, we went to see the Fanuc EDM event. Have you got any feedback from that as well?
I think that reiterating what Paul said, really, I think that, and knowledge and what you said, really, we're kind of supplying knowledge to people that are not knowledgeable in this area, in this arena. And I've been speaking to people that are actually selling these machines, and they've reinstated exactly what we've said. They believe that people are not embracing this technology because they're scared of it, because they've never used it before. So the more we're showing it, and more we're showing examples of applications in which it can be used and the savings that can be had from this technology, I think that it's starting to install confidence in people, and it's started to definitely get people inquiring about this technology.
Are you saying that you think we're responsible for the fact that they're selling more machines?
Partly responsible. I think that,
it's true. We're a major platform at the end of the day. If we're talking about something and people are learning, then it's going to have an echoing effect.
Education and learning. I think that if you don't know about something, you're not confident in something, and you won't invest in it. And ultimately, that's what it's all about. It's learning about knowledge.
And that's
Mark,
power.
you're right.
No, don't tell Mark that he's right. But honestly, if you have a success story, we would love to hear from you on EDM or anything at all, and you too can be featured on the next Swarf and Chips. So next up is Geo. Now you try and explain to us the difference between full 5th axis and 3+2 at Advanced Engineering UK Ltd.
This week, guys, we have travelled to Advanced Engineering UK Ltd in Birmingham. We discuss 5th axis machining all the time, but what's the difference between full simultaneous 5th axis machining and 3+2? Well, hopefully I can go into that in a little bit more detail. Now, if you're 3+2 manufacturing, you are using the Z, the X and the Y axis, and then you're independently moving the A axis and then the C axis. And it's as simple as that, really. When you're programming, or you buy a machine which is full simultaneous, all axes move at the same time. So an example component of full simultaneous machining is like an aerospace blade. You don't obviously need full simultaneous machining all the time. You can do pretty much what you'd need with 3+2, but it's a very nice to have luxury item if you have it. I hope that has clarified it to a certain degree. Back to you in the studio.
So, Paul, was he the G-man?
I think he did a good job. I think what I liked about this as well, though, is it's beyond the 5-axis bit. This actual machine, I know we've highlighted this, I think it's an i700, is it?
It is correct, yeah.
Before, when this door's open and you go inside it, at the perfect time in there, look at the space. And it's not just that Geo's small that he fits in there. Genuinely, it is a very spacious machine.
In the machine.
I mean, accessibility is incredible, isn't it? Loading that table, walking into the machine, loading that table, the construction of this with that bridge means that the tool changes at the back of the machine. I know I'm not talking about the full 5-axis.
No, I'll ask you that in a moment.
He's done that perfectly well, but I do pick out when I look at this. I think what stands out to me is that 5-axis machine.
Okay, so Paul, what is the difference between 3+2 machining and 5?
He's just told you.
No, go on. You say. You go on.
Well, to me, it is exactly like Geo said. You've got 3 axes moving. And 2 axes moving separately, so that is 3+2. Whereas if you want all 5 going together to create a component, that's full 5-axis.
And does that change all your programming and everything?
Yeah, you'd program it differently. But one of the things you'll notice is I did that in 10 seconds. It took him a minute. I should say what I was doing is reiterating what Geo said.
Did anyone catch that?
I got a bit tongue twisted.
You made up a word, Geo, at the beginning of the show.
But full simultaneous is used now. I mean, there's lots of new processes and new technologies that are coming into play from software companies, in particularly like conical barrel cutting, for example, where you need full simultaneous. So processes of developing and improving. Subsequently, you need full simultaneous, but there's still a lot of applications where you'll just need positional. So you can use your 5-axis machine just for positional purposes to do 5-sided work, 6-sided. Well, the 6th side is the second operation, but 5-sided work. So again, going back to the video, there's applications that lend themselves to full simultaneous, and there's lots of applications that still lend themselves to 3+2.
Yeah, I remember being at DMG. Oh, sorry, Paul.
No, I was just going to say, so that's now 3 minutes.
Sorry, Paul. I remember being at DMG more the entry-level machines were more the 3+2, and then you it's like the next grade up. But a lot of people, they didn't really need the full simultaneous, so they pulled it back and they still got even more output from the machine anyway. So.
And I think that another point is really now is you're kind of future-proofing yourself by having full simultaneous with these new technologies and processes available in regards to the software that's available, which then enables you to produce components in a different way. And, you know, used conical barrel cutting, for example, which you couldn't do on a 3+2. Sorry,
I mean, 10 minutes, Gio, really? Yeah, fabulous. Right, don't forget, by the way, to comment and subscribe on the shows, and, you know, put your comments below. We like to have a bit of a laugh too. Do you have a 5th axis machine? You know, what components do you make on it? Please do let us know. Next up, Gio, you're at it again. This is going to be a long show. This time, your favourite subject, workholding.
This week we're discussing workholding options for a CNC single spindle lathe. Your most obvious option will be a 3-jaw power chuck. Now, what are your considerations when choosing a 3-jaw power chuck? One of your considerations should be the through bore of the chuck, so it matches with the machine spindle bore. Another consideration should be the length, so you utilise the envelope of your machine. Now, power chucks are predominantly for billet work, so you've got lots of jaw options, such as hard gripper jaws for op1 billet work to bite into the billet, soft jaws for second op work, so you can bore them out to suit the dedicated size, and full wraparound jaws if you're doing thin-walled work to stop any distortions. What other options are available for a single spindle CNC lathe? Well, you can put a collet chuck on there. So if you were looking to add a bar feeder and feed work through, you can put a collet chuck on there with dedicated collets for dedicated sizes of bar. There are lots of other options available, but these are just a few that should cover most applications. Back to you in the studio, Lindsay.
Oh, you are fabulous, Gio. So why are you doing videos like this?
I think it's through demand, really, Lindsay. I think that our audience are demanding us to do these videos. There's a lot of people that are watching our content that want to learn from the content that we're giving to our audience, and subsequently, I think that, you know, we're taking it back to basics for, you know, the young budding apprentices out there that are watching our show. But we're at the cutting edge of technology as well. So I think that we're trying to kind of accommodate for all of our audience.
We often take for granted some of the knowledge that you pick up, you know, as you travel around. But things like this, going back to basics, has been requested, and people asking, saying, you know, can you tell me the difference between this and that? And whether he gets it right or wrong is a different.
Or takes 10 minutes over it than just 30 seconds. You know what? When we went to Timtoff, well, yourself went to Timtoff, and there was a lady on there, and it was very nice. But she said, "I learn with you," and I thought that was really, really nice. So these shows are for everyone. Look, if you have got any questions as well, write them in, send them in, and we can do a video on them as part of the show and answer those questions regarding anything workholding, EDM, anything.
There was one point, you know, you talk about 3-jaw chucks, that there's quite an innovative 4-jaw chuck I've seen, like the inner flex and things like that, where they self-center. You know, and I know this is basics, but work holding essentially with chucking can go to, you know, to so many lengths.
On that particular chuck, we've just done a technical corner on that chuck, so that'll be on our site at any time now. It might even be on the site now, but
it still puzzles me how it all works. But I'm sure you can watch that.
It's like two centric grippers, basically. So if on a mill turn machine, for example, it's perfect. So when you're feeding round bar on a mill turn machine, it's just predominantly for round bar, but with this, it works as a 3-jaw and a 4-jaw. Oh. So you're getting the best of both worlds. So you can also load irregular shaped billets into your mill turn machine. So it gives you the best of both worlds.
You're a fountain of knowledge. So next
and that's power.
And then knowledge empowers. No, we'll stop. Right, okay, Colin is up next. He visits Truturn with a citizen machine review.
Brexit woes, not a problem here. Truturn Precision in Stroud. What I want to talk through some of these components, because you're exporting around the world. A great example is the Far East, so you're expecting things to come in cheap and cheerful, maybe in from China, but these parts are going out to the Far East. First of all though, new machine?
Yeah, new L20 LFV. It's been installed now for about 6 months, so we've really got to see all the pros and cons, and most of them are pros, so yeah, really good at the moment.
All of them are pros?
Yeah, that's it.
But what I want to do, I mean, we said about exporting, these are some of the parts. What are they, and how has LFV improved sort of cycle times, etc.?
Yeah, so you're looking on a general cycle time on a part like this, we're looking anywhere between sort of 20 and 30% increase in production, so a reduction in time. We're seeing better finishes, less swarf damage through the clearance of the swarf through the LFV. Basically meaning that we have to make less parts to fulfill an order, less scrap, less time in inspection, and everything's just sped up basically right the way through.
Winning all round. So essentially, because of the LFB, you're not getting that swarf ingress, so the finish on these is much, much better.
Yeah, exactly. Yeah, exactly what that is.
Because what sort of, in terms of finish, what sort of tolerances has got to go to?
So you're looking 0.4 across the heads.
Yeah.
You're looking at like a 1.2 finish down the stem, but it's a very integral part of what they make is the finish down the heads and the stems. So any sort of indents, swarf indents, scratches, things like that is basically either a rework by hand or an instant fail.
Okay. So really, it's just a great example, of investment and UK manufacturing. So Brexit, what Brexit?
Absolutely, no worries there. Then is there?
No. I didn't catch it. Did he tell us the volumes that they were making? I know they'd won the work back from abroad, but it just shows you that a 20% in an improvement in cycle times is winning them that work, and that's how important that saving is to be able to,
But it's not just about cycle times, is it? With a lot of the Citizen machines, it's about the quality of the finished part as well. That there's
I suppose it's getting rid of all those kind of laborious and labour-intensive issues that you may have without being able to get the process, the security process, as he says, better on the machining.
Yeah, that's
it's creating that unmanned running, isn't it, overnight, confidently, without worrying that you're going to come into a bucket of scrap. You know now they can run it confidently and run it 24/7.
And he's becoming an expert, old Colin, now, isn't he? Many subjects and topics.
I've noticed this man's
machine
knowledge,
sensors.
this one here, his knowledge has improved greatly since being here.
Yes, it has, isn't it? And sometimes the questions he asks, ones we might not think of. So
Sometimes I might though. But you know what? Sometimes the more innocent you are, you can ask the most taxing questions.
Colin, I want to do that.
Maybe he's not innocent. Right. Anyway, next up is your chance to get involved with a cycle time challenge on another Citizen machine.
Guys, back again. I know you love my cycle time challenges. Now, first of all, I do apologise if there's any sniffing going on. I've got a stinking cold. I blame Jonesy because I was on the phone to him last night and he's got a cold. So, moving on swiftly, Finetec Precision Bridport, new Citizen L12 LFB. Just want to showcase what they manufacture. Look at that. Now, that is a nut. As Chris smacks me in the forehead with his microphone on the camera, but if you could pick that up, that's not what the cycle time challenge is. I just want to showcase that little part. Right, if I could just pop that down without dropping it, because that's one of 2,000. They've counted them all out, and I don't want to ruin their batch run. Now this part here, a piston rod, and I got told off the other week because I didn't mention what material it is. So Peter Pedantic and his friend Lindsay, there you go, piston rod, EN19. Now look at that, threaded, all done in one pass, little drilled hole there. Now this was previously done balance turned in 90 seconds. What I want to do though is I'm going to change it up as usual. I want to know, there is normally with LFA they don't normally get a cycle time reduction, it's more about process security, but there is a cycle time reduction. So previously 90 seconds, a piston rod, but what I also want to throw at you is before balance turned, so 2 inserts, they were changing them every 25 components. Now they're only doing it with 1 insert. They don't need to balance turn it. So how many components do I do per insert? I'll give you a clue. More than 25. That's it. Back to the studio. I hope I get everything right this time.
No, you've got nothing right, Colin. That's it.
It's confused the hell out of me.
Yeah, it's confused me.
Okay, let me explain. I think I'm more on Colin's level. Basically, he wants to know the cycle time, but also how many inserts did they get through?
How many parts
did they get through?
Per insert.
Yeah, per insert.
And before it was 25.
Yes, and now
I'm going to double. I'm going to say 50.
Okay.
50, yeah, because that's a phenomenal saving.
Okay, and then the cycle time.
Cycle time of that 50 seconds.
Okay.
Yeah.
Right then.
I'm going to say that the tool life's going to last even longer than that because you're cutting right next to the spindle all the time, right? So I'm going to go 150.
Right.
And then I'm going to say maybe, 60 seconds.
Okay. Right. You know what? It doesn't matter what they think, because all that matters is your guesses for the Cycle Time Challenge. Make sure you put your guesses in the comments box below, and it's both guesses that we need. We'll be announcing the winner on next week's show, and you can win a Swarf and Chips goodie bag. So anyway, thank you so much. We really hope you've enjoyed today's show, and next week we travel to Coventry for the NCMT Affordable Excellence Open House event. So please come and join us on Swarf and Chips. Don't forget to like, comment and subscribe, and as we always say, keep those spindles turning. That was so cheesy.
It was really cheesy.
It's fine.
It could still be.